Hi, thanks for joining us today on Uptime Logistics. I'm your host, Doug Draper with the Denver Transportation Club, and we have a phenomenal guest today. We're going to learn about a lot of different things related to cement, concrete, and infrastructure. So I'd like to welcome our guest. It's Brian Armstrong. He's a project manager with Kiewit Infrastructure. So Brian, thanks for joining us today.
Yeah, thanks, Doug. Good to be here.
Yeah, awesome. Before we dive into our topic, I think it's great if our audience could learn a little bit about yourself and kind of your background. And before you jump into there, I'm going to set the expectation really high because the title of this podcast is Musings from a Concrete Aficionado. So there's your title, my friend. You have a lot to live up to on this one.
It's kind of funny you titled it that because I really love working with concrete, and I've been doing it for about 20 years now, all with Kiewit. And I guess going back before then, I'm originally from upstate New York, real close to Cooperstown for any baseball fans out there. I was actually born in Cooperstown. So I spent my childhood in New York, and then after college moved out to Denver and joined up with Kiewit here. And started on the T-Rex project, actually. So I've been a part of major infrastructure projects in Denver for 20 years, my whole career with Kiewit. T-Rex, a couple other smaller jobs around here, and then Denver Union Station. Built the underground bus terminal and train hall there. And now Central 70. So I've been a part, like I said, of major infrastructure projects around Denver, and been able to place a lot of concrete in Denver. And it's neat to see the evolution of the industry and the science behind it as things have progressed here.
Yeah, cool. Well, I moved to Colorado right when T-Rex was in full force, so I remember that for sure. I think you guys, not you particularly, but the project itself got a little bit of a bad rap. I mean, what are you supposed to do? You're trying to widen a road, right? Hey, we were talking off air a little bit about Kiewit, the company, and you brought up some cool things I did not know about it. So maybe you could tell a little bit about Kiewit, its origins, and a little bit about kind of the organizational aspect of it.
Yeah. You mentioned T-Rex getting a bad rap, but usually people hate us until we're done with the project. And that's how it goes. Everyone hates you until it's all done, and then it's all high fives. But so Kiewit started, Peter Kiewit in 1884, started as a mason company, and has evolved since then into a full-blown general contractor, engineering design firm. We do a lot of our own design, both temporary, for construction, and permanent design. Range across every facet of construction, from infrastructure, transportation, to water, wastewater, power generation, mining, and commercial building, vertical construction as well. It's an employee-owned company, which is something I really like. I'm a part of the company, and you have that vested interest in it, and everyone you work with has that vested interest. So 125 years. Primarily North American company, although at times we do expand outside of North America, depending on, the markets and what is beneficial for the stockholders.
Yeah, great. Well, perfect. I was saying I wasn't sure if Kiewit was an acronym for something or what, but it's 125 years old out in Omaha, Nebraska. So that's awesome. So let's kind of start off really simple, right? Because I think the term concrete and cement gets used interchangeably, almost like, Kleenex and tissue. So before we kind of jump into how concrete works, maybe the different types, Why don't you quickly give what's the difference? I think one's an additive and one's the finished product. So what's the difference between cement and concrete?
Yeah, you hit the nail right on the head there. Um, Cement is an ingredient in concrete. So concrete is made up of cement, sand, aggregate, rock, and water, essentially. And those those basic ingredients make concrete, which is what you see on your sidewalks and driveways and roads, bridges, that kind of stuff is actually concrete.
Mm-hmm.
And cement is in the form of a powder, and it's what makes the concrete hard. When cement mixes with water, chemical reaction of hydration um, makes the concrete get hard, and then you have the sand and the rock in there to one, create volume, and two, the rock intermixed with the cement adds strength to the concrete.
Nice. And kind of like, there's beer aficionados out there, right? Each beer takes a little bit of special ingredients. And when you and I were talking, I didn't really realize there was kind of different types of concrete. Maybe you could talk a little bit about, I refer to it as horizontal and vertical building, and then there's obviously barriers and structural integrity and stuff. And maybe not go into extreme detail because I think there are a lot of different type of concrete, but maybe go through some of the basics, like a road type of concrete versus a column you'd build for a bridge or even a high rise, and then maybe barriers. Talk a little bit about the differences and what those are.
Yeah. So, like I mentioned, you have the basic ingredients of cement, water, and aggregates in concrete. Then there are a million different varieties that you can do with admixtures in the concrete. Admixtures are chemicals added to it to do a multitude of different things, depending on how you want the concrete to react while it's still plastic or liquid, and then how you want the strength characteristics of it, how quick you want it to set up or get hard. Um, so you can have concrete that sets really fast, which would be advantageous if you're doing a repair in a roadway and you have to get traffic back on it quick. You want something that gets hard quick so cars can drive over it. You'll put what's called an accelerator in it, and that basically triggers that chemical reaction of the cement and the water sooner so that you can get the strength and drive on it. Um, then you also have stuff that can slow down the set of concrete, and you kind of wonder, well, why do you want it to slow down the set of concrete? And it's real simple. When you're placing concrete, you want it liquid, so that as you place it, it mixes together and becomes homogeneous, all as one unit. And if you're placing at a slow rate, example would be a tall wall. A lot of times you have to slow down the set a little bit so that as you place different lifts of that wall and come up the wall, the stuff at the bottom isn't rock hard and you don't get that mixture between the two layers. And then there's other additives. You can add what's called fiber mesh, which is just that. It's fiberglass mesh that's added into the concrete. It adds some internal strength to the concrete. We use that a lot of times on sidewalks, curb and gutter, barrier. You use that because concrete, kind of a joke in the industry, is that there's concrete that has cracked and there's concrete that's going to crack. And concrete does crack. It's as it gets hard and the water evaporates out of it, it also shrinks, and that's part of the cracking process. But what you don't want is those cracks to propagate into something that's detrimental to it. So that fiberglass internal reinforcement will stop a crack from growing, and you just get micro cracking within it. And much more durability, longevity on items like sidewalk, stuff like that.
Yeah.
And then probably the other big difference in concrete is the strength characteristics of concrete. The strength of concrete is primarily measured by compressive strength, how many pounds per square inch it can withstand before it fractures. Pieces like your driveways and your sidewalks typically don't have the same strength of concrete as a bridge would, right? Because they're not put up to the same test over time. So, bridges, structural elements are going to be, a higher strength concrete than something you're doing on a sidewalk. And really, that's just the amount of cement that's added into the concrete. So you want higher strength, more cement that goes into it. And cost goes up a little bit, obviously, because of that.
Right. Yeah, for sure. Yeah, it's funny on the additive and the fiber. I distinctly know that when you reset a sidewalk or something, you see these little micro fibers, and I've always wondered, what would somebody leave something behind or whatever? But it makes total sense. Obviously, this is a logistics show, so we need to talk a little bit about logistics, right? I know that we've used the term when we were talking about, setting up the pour, right? Exactly what transpires at the job. So walk us through, let's use the I-70 corridor project. I drive it every single day. And you got guys out there getting ready to do concrete. So you're in the moment, right? You got to take care of this barrier or this bridge or whatever, but you're not making the concrete right there on the road. So when you talk about setting up the pour, talk a little bit about how that works logistically, because you got to have enough trucks to come in to pour it. They don't need to be there too soon or too late. So you have all these timing issues that people may not think about. So walk us through setting up the pour and then how you manage the inflow of the concrete to make sure it sets up correctly.
Yeah, absolutely. And you mentioned being in the moment, but really a pour, especially a large pour, and I'm going to use a bridge deck as an example. We've poured a couple of those here in the past few weeks. The setting up the pour starts about 2 weeks before we actually pour. We start coordinating with our supplier to make sure that they have the proper amounts of sand, of rock, of cement that we're going to need on that day. A bridge deck pour, we're looking about 300 cubic yards of concrete. So to put that into perspective, each truck that you see driving down the road holds 10 yards of concrete. So we got 30 trucks coming over about an 8-hour period. So we need to make sure first that all that material is going to be ready on that day. So we start coordinating, timelines. Now, one of the great things about working outside, pouring concrete outside, is you have Mother Nature to deal with. So, we usually set up a day we're going to pour, and then we'll set up a backup day that's not the next day, but it may be a couple of days down the line. So if we do get a weather system coming through, it doesn't affect both days that we have scheduled. So first thing we do is, we'll set a date and do that. And then we need to, like you said, figure out how we're going to get the concrete to the site and then timing on it. And a lot, that's your rate of placement. We look at, how quick we're going to be able to place and finish the concrete. One thing, that once they add the water into those trucks, that chemical reaction of the hydration starts happening even while it's being driven to the site. So we have about 90 minutes from when the water is introduced with the cement to when it has to be discharged from the truck. So you don't want all 30 trucks showing up in the first 10 minutes, and then sitting there, because by the time you get to that last one, it's going to be hard inside the truck, and that's a bad day. So we set it up, if we, based on past productions and everything that we do, a bridge deck, we're usually pouring about 50 cubic yards an hour. So we want 5 trucks coming every hour, which is roughly, every 12 minutes, we want a truck being batched. So that's how we set it up with the supplier, is every 12 minutes, I want you batching a truck, and then drive times being similar, they all show up about 12 minutes apart from each other throughout the day. And then,
Nice.
You have to have access for them to get into the site, so, how are you going to get it there? What haul roads are they going to use? And then lastly, you think of a bridge deck before it has concrete poured and hard on it. Well, you can't drive trucks on that. So how do you get the concrete from the ground up onto the bridge deck? And we do that with concrete pumps. It's a boom mounted pump on a truck, and come in multiple different sizes. So again, we need to find out what size concrete pump we need and where can we put that concrete pump to reach every section of the bridge. So we measure all that out, size up our pumps. Sometimes it's more than one pump. We'll have to move them from one place to another because we just can't reach everything with a single pump. And then get all those logistical items figured out well in advance of pour day. And then it comes the day to pour, and these trucks start coming in, right? And inevitably, we do testing on site, quality control testing, right? And that will ensure that the concrete has the proper amounts of cement, water, admixtures in it. In Colorado here, we have freeze thaw conditions, so they introduce air into the concrete, little microscopic air bubbles that can take the expansion and contraction. We test that as it comes out here too. But as you start pouring, you're going to get a truck that fails, right? And the concrete's no good. So all this perfect planning that you had done, getting your spacing and everything, well, you just threw all that out the window. And then it becomes time to react, and we're in constant communication with our supplier. It's kind of cool. We actually have an app on our cell phones. We can tell where every truck is, what truck's being batched at the plant, if a truck's left, where it is en route. So we can see all that stuff. And if we get a truck that fails, well, we're going to have to get a replacement truck for it, right? And we don't want to wait an hour for that replacement truck to come because the concrete that's on site's already getting hard at this point. And like I mentioned, you got to keep that mixture going. So, through an 8-hour day, we're making lots of adjustments throughout a pour to keep that coming as we go. And, then you get to the end, and hopefully everything went as planned, or adjustments made as needed. But it's a lot of upfront planning to make a pour, and it's not just what you see when you're driving down the road of concrete being placed. It's the time spent up front to make sure all that stuff happens right.
Yeah. Yeah. Well, Brian, you should be the host of this show because you've already tapped into a couple of questions and points. So nice job. You have a good flow with your discussion. So we are Uptime Logistics, right? So I want to take a step back to oh my gosh, what do we do now, right? So you want to maintain that uptime, which is critical. And, if you have a pour and the truck's late, like you said, you only got 90 minutes before the concrete is bad. So you talked about tracking capabilities and where is the truck and things of that nature. So let's say that all of that fails, right? And you're sitting there, the concrete on the truck is late, so it's not in the right conditions, and you're communicating, the guy's down the highway, but there's a wreck or something. Do you ever have to stop and just say, listen, we got to reset for tomorrow, or we need to destruct some of the concrete that we just poured because we can't link them together? So talk about some of the fixes or things that you do to react if there is a problem to keep that uptime. I don't know if that question makes sense or not.
Some pretty good examples. So part of the planning that we do when we're setting up pours is where can we make an emergency stop of the pour if we need to, whether it's concrete issues, weather, whatever it may be. If we get partially done with a pour and just can't go on, is there an option to put, to stop a pour and put what we call a cold joint in the pour, construction joint? So we had those predetermined. That's ideally what you want to do, because then you can pick up tomorrow and just resume from where you're at, and finish out the pour. But in some cases, that's not an option. It just doesn't work. Or you get concrete that you place and later find out that for some reason it just doesn't get hard, right? That's an example we had out here just a week ago on C70. We had placed some barrier, and several hours after the barrier was placed, the concrete just wasn't getting hard. And we went through all the testing that we do up front, and everything appeared good with the concrete. It just never got hard. And what we ended up finding out is the supply of what's called fly ash, which is another additive in concrete. Fly ash is used as not a replacement, but a substitute material for cement. Fly ash is cheaper and has a lot of the same characteristics as cement. So some fly ash gets mixed in with the concrete along with cement. We had some where basically there was a contaminated source of fly ash with our concrete supplier. So that contamination prevented the concrete from getting hard, and just never got hard. So we had this barrier that was mush essentially, and that's not what you want to keep you from driving off the side of a bridge, right? So then it comes into we have to remove and replace that bad concrete. So we we'll saw cut it, demo it out, and rebuild it. And that's, of course, that's worst case scenario. Usually, like I said, we want to stick with the option A of having our plan where we can stop a pour and pick it up the next day.
Yeah. Yeah, that's great. You talked a little bit about the testing aspect of it. So obviously you're testing a little bit as consistent testing to make sure that you don't pour something and 6 hours later you go back and realize it's not appropriate. So I'm envisioning some guy with a notepad and a white coat walking down the road and checking things to make sure it's okay. I'm sure that's not correct. I'm being facetious, but tell us what that testing process is. Is it machinery that does the testing? Is it literally a human that comes out and kicks the tires, so to speak? Talk about the testing process and what takes place to make sure the concrete is safe.
So they aren't wearing white coats, but on Central 70, all the guys wearing white hard hats are our inspectors. So
nice, good.
There are inspectors and testers, and really the testing and inspection of concrete starts well in advance of placing any out on site. We do trial batches where we just get samples of concrete to come out. We pour what are called cylinders, but they're 4-inch diameter, 8-inch tall cylinders of concrete, and we store those for 28 days. And this is all from the trial batch. We store them for 28 days. At the end of that 28 days, we put them in a press, essentially, and start applying a load to it to see how much strength is in that concrete, right? And we make sure that, if it's a 4,000 PSI design strength, that in 28 days is kind of the industry standard for achieving full strength of concrete. So we make sure in 28 days that we get the strength that's required. In that trial batch as well, we're going to analyze the amounts of rock, sand, water that's all mixed in with it. We're going to test the air content on it, the entrained air content. We're going to test what's called the slump, or that's how much water is mixed in with it, how fluid it is. We do all that testing on trial batch to make sure that we have a good design mix first. And then so we go through that, we we've confirmed it. We have a good design. Now we start going into actual production. And when we make pours out on the site, we do that same testing process. We'll test the air and slump prior to any placement. The air is simply you put the concrete into a metal pot, you induce some air into it. You see how much of the concrete, how much of that air actually gets into the concrete, right, and fills up those microscopic bubbles. And then you can tell what percentage of entrained air you have in it. The slump, you check the amount of water that's in it. We do those two tests prior, and then we also cast those same cylinders when we're making pours. So you make the pour, you get those cylinders, they go back to a lab, they're cured in a steam room, the same conditions that the trial batch was cured in. And then after 28 days, we break those cylinders for the in-place concrete, just the same. But by making the cylinders, we're not doing any destructive testing to what's out there. And when we break the cylinders, if they have achieved the design strength, all is good. We move on. We do have sometimes, though, where, just like the concrete that never got hard, sometimes you get concrete that just never got hard enough. And the unfortunate thing is you don't find out until 28 days later. But you do have cases where concrete just didn't get hard enough. And then you look into, corrective measures for that, right? Is it a removal and replacement? Is it strengthening it from some sort of external means, depending on what you have? You can go into that. But, after the 28-day period, we have all testing results to show that what we have placed out there is in accordance with the contract specs. And, we don't test every single load that comes out, but we test, the first few trucks. And then once we know, starting on a day, once we know that the plant, that gives us the ability to tell that the plant's calibrated correctly, right, by testing the first few loads. And then we'll test random loads out of every 5 to ensure that nothing is happening as we're going through the day.
Yeah. That's good to hear, to be honest with you. That's a lot more testing than I would have thought, especially in advance. You're testing it before you even get on site. That gives me peace of mind as I'm driving down the highway that it's been tested and retested and inspected. So that's good news. And the cool thing is that when I'm driving with my kids next time on I-70, white hard hats testing slump, I'm going to look totally cool because I'm going to tell my kids, hey, that guy in the white hat, he's testing the slump of the concrete. And they're going to say, what does that mean? And I'm like, you got to call, I got a guy, Brian Anderson will take care of it, or Armstrong will take care of that. So, hey, last topic I wanted to go into, and I really appreciate all the things you've been talking to us about, is maybe some new technology out there, right? So you've talked about some amazing processes, some safety precautions and testing. What do things look like 3-4 years out? Is it faster pours? Is it new additives? Talk to us about what a job site would look like 5-6 years out from now related to concrete.
I think the biggest changes you'll see is stuff you don't really see. As odd as that sounds, it's going to be with the science of concrete, and you see a lot of it happening and already, but it continues to evolve. The admixtures in concrete, the science behind it, it's a lot different than what it was 100 years ago. 100 years ago, it was strictly cement, sand, and water and rock. Now that we have the ability with all these chemical admixtures, we can control what we want the concrete to do a lot more. And you see a lot more of that. And, a job I worked on back in about 2016 in Nashville, we had a concrete mix that it was essentially bubbling when it came out of the truck. There was so much chemical reaction going on. But that concrete went from a liquid state to being able to drive on in less than 4 hours. And it was part of a bridge. We were doing accelerated bridge construction there in Nashville, and we could have the bridge open after pouring that concrete within 4 hours with the accelerators and everything we had in it. And you're going to see a lot of that, a lot more of that, a lot, as we continue, which is going to make things stronger, more cost effective, and essentially faster production. If you can get strength quicker, you can move on to the next step of your project quicker, right? You don't have to wait 30 days for this bridge deck to gain strength so that you can start putting traffic on it. You can wait, 7-10 days and do the same thing. The other thing that's pretty cool, it's related to concrete, but what you're going to start seeing a lot more of is what we're calling smart pavement. You see a lot of automated vehicles coming out now, self-driving cars, self-driving trucks. Well, they're working on technology, and we've actually done some trials of it here in Denver of smart pavement, where there's sensors and technology cast into the concrete pavement that talk to the cars, and that'll help for a multitude of different things, whether it's traffic control. If there's a spot on the highway that's got an accident and traffic's jammed up, the road's going to be able to tell a car 10 miles back up the road, hey, traffic stopped up there. It'll tell the car to slow down to, maybe slow down 15 miles an hour, so that when you get up to that accident, you don't come to a complete stop, right? It avoids that stop and go scenario. It also can tell if a car diverges from the road or goes off the road, which could be really advantageous, on some of the mountain roads up here where, may not be that much traffic, but you get someone that goes off the road and someone doesn't, and no one sees it. The road can actually sense that and send an alert to emergency services to go check out that area. So I think you're going to see, in the next 5 to 10 years, you're going to see a lot more of that advancing. It's going to parallel with the automated driving, and move forward with that. So that's a pretty cool thing. It's really neat. You just go from a hard surface to drive on to something that's actually working with your vehicle as you're going through it. Yeah.
That's really cool. I mean, that could be a whole show in and of itself, the connectivity and the Internet of Things. That's pretty amazing. I can't even believe that is just a few years out. So Brian, I can't, thank you enough for joining us today on the show. I truly learned a lot. You're going to make me look like the cool dad when I reference white hats for inspectors and testing slump. So thank you for that. I owe you a beer, and really appreciate you and Kiewit coming on and talking to our audience a little bit about concrete. You are certainly the aficionado. I will give you that. So, and I'd also like to thank our audience for joining us today on Uptime Logistics. It's powered by Cap Logistics, and you can find more information at the link below. And we hope that you join us in the future for another episode of Uptime Logistics. So until then, everybody have a great day.